Okay, the last portion of section 8.1, refers to problems that we run across in calculus or come across. And in 10.1, the last section, we're going to deal with the same idea. These are derivatives. You take a derivative in calculus and you end up with this, two things added. And the goal is to figure out where this equals 0, so factoring is a must. So if I look at those terms, I notice that 2x plus 1 is a common factor in both. That's the only thing I see common in both. So if I take the first and divide it by this, I'll have 5 into 2x plus 1 to the 1 left, plus, if I take this piece and I divide it by this, I'll have 2 times 2, which is a 4 into 5x minus 6. The goal is to figure out where this equals 0, so it's important that you're able to factor this all the way. This is 10x plus 5 plus 20x minus 24, and that will be 2x plus 1 into 30x minus 19. If you distribute and FOIL, you could make this problem a lot more challenging than it is. So factoring is a very efficient way of getting to your answer. And now you can tell x must be negative 1/2 and 19 over 30. And again, all of these problems are what's known in calculus as a derivative. If I glance at this, I notice there is an x squared that's common in both. I factor that out. I said x squared and I put it. If I take this first divided by this, I'll have 3 into 8x minus 3, plus, if I take the second term divided by x squared, that will be 8x. And now all what I have to do is factor this out completely, 24x, or simplify this out completely, I should say, and that will be x squared into 32x minus 9. And I know that in this case x would equal 0 and x would equal 9 over 32. That's something you don't have to do, but that's where we're going with this. In calculus, you're going to have to get this derivative, this value, and set it equal to 0. And that shows to be more challenging to students than the traditional. And that's why we're doing it right now. If I want to factor here, I notice 4 and 2, I could take a 2 out. I notice an x plus 5 to the third and x plus 5 to the fourth, x plus 5 cubed, and an x minus 1 is common in both. Now, if I take this first term and divide it by this factor, what would be left? The 4 divides into 2 times. The x plus 5 to the third power cancel out. When you divide those, you'll have 1 left. Plus, when you take this second factor, or term, divide it by this, what would be left? Well, the 2's cancel out. The x minus 1 cancel out. X plus 5 to the fourth divided by x plus 5 to the third, you'll have x plus 5. Again, foiling this is not a good option because you need at the end to go back and factor it, because you need to know where does this equal 0. X plus 5 cubed, x minus 1, 3x plus 3. I could factor a 3 out, but that's sufficient since I know now x equal negative 5, a 1, and a negative 1. Those would be the zeros of this polynomial. Same deal with this problem. I'm glancing at this and thinking, okay, what's common in both? I see they both have a 3. That's very good. I'm going to take a 3 out. They both have an x squared. I'm going to take that out. And they both have an x, 3x plus 4. That's how we factor. Take the one with the least power. Now, if I take this divided by this, the 3x squares will cancel out. I'll have one of those left, plus, if I take this divided by this, 3's cancel out. There's a 2. X cubed divided by x squared is x. So that's 3x squared into 3x plus 4 into 5x plus 4. And there it is. Where would this equal 0? At x equals 0, at x equal negative 4/3, and at x equal negative 4/5. Very important to do. And the last example I have, and those are important enough for me just to dedicate a special lecture just for them. If I want to factor, I'm glancing at both. 3 is not common in both. There is something common between the 4 and the 2. 2 is common. They both have a 4x plus 5. I take the one with the least power, which is a 2. And they both have a 5x plus 1. And I take the one with the least power, which is a 1. Now, if I am to take this term divided by this, 4 divided by 2 is 2. There's also a 3. This cancel out completely, and one of those will remain. Plus, if I take this divided by this, the 2's cancel out. The 5x plus 1 cancel out completely. I'll have a 5, and 3 of those cancel with 2 of those. I'll have 1 left. 2, 4x plus 5 squared, 5x plus 1, 6x times 5 is 30x, 6 times 5x, I mean. 6 times 1 is 6, 20x plus 25, a 2, 4x plus 5 squared, 5x plus 1, 50x plus 31. And there it is. We're going to factor something just like that when we get to the radical part. And they're going to look slightly different, but the same idea. They're going to look like this. We're going to follow the same trend. So make sure you work those out. Give it time. Don't rush. And try and understand how this works. And there's your homework.